Hello, ladies and gentlemen. This is Mr. Green, and this is another in a series for Algebra 2 students. Welcome to TOPS Algebra 2. This lesson is dealing with some new things in Unit 4 because everyone should be finished with all the stuff in Unit 3. Should have all the quizzes done, tests, everything like that. Don't forget, I do allow quiz corrections. It doesn't say anything about it in the course. If you make corrections, make certain you're telling me how you're correcting it, showing me some work. Send it to me via Kmail, and I will accept it, okay? Corrections have to be done before I lock the item up, so please make certain you get them in to me. We'll go from there. First of all, the lesson that we're doing today is over 4.01, inequalities, okay? Inequalities. That means they're not necessarily equal, are they? So we're going to just deal in one variable, so it's going to be a little bit easier, but we'll make certain we understand them. A bounded inequality is one where I have both ends of an inequality and they're both solid points, meaning that we've got a greater than or equal to or a less than or equal to at both ends of the equation. Okay? That would be something like x is greater than or equal to -2, which is less than or equal to 2. Okay? Could have written it the other way around. I could have said -2 is less than or equal to x is less than or equal to 2. That would be this one here. It is bounded. See the equal signs there? That means that they're solid in at both ends. I could have an unbounded one. That would be like saying -2 less than x less than 2. See how I have opens there? I would have open circles in both of these two locations here and here. Okay? This one is a half-bounded interval. That would mean something like -2 less than or equal to x less than 2. See how one of them has got a less than or equal to and the other one's got just a less than? You can tell them apart that way. Okay? By the way, how I'm telling these apart on the screen in case you can't see it, the red dot, I don't see any black through it. The open circle, I'm seeing the black when I'm seeing the open circle go through there. Okay? That's how I'm telling them apart on that particular screen. Okay, the interval notation, I've already pointed that out. If I've got a less than symbol, I'm going to have an open circle, and it's just going to be going that way. We have a type of notation called an interval notation. In this particular case, you would say x is all the values, x includes in this set, and you'd put an open bracket, an open curly, parenthesis there, a comma infinity. Why? Because it goes on for infinity this direction. It never stops. Both of them are open brackets. That's what we would use in this situation because this one is unbounded and infinity is unbounded. So you put open brackets at both ends. Whereas on this type of an equation where I've got some bounding, see I've got the less than or equal to sign, it's solid in circle here. I'm putting a square bracket. The difference between these is the A will get that square bracket in that situation. Okay? Because this one is indicating greater than or equal to. This one is just indicating greater than. Now, infinity never gets a bounded sign. So you never put a square bracket on this one. You always have an open bracket. Why? Because infinity never ever ends. You can't get to the end of it, okay? By the way, that little symbol is read as an element of. So you can read it as x is an element of, and then give it the set that it's an element of. That's why we're putting it in set notation like this, interval notation. Okay? So let's go on and look at how we would do some things here. If I wanted to do x greater than 3, I would start on my graph, I'd put 0, I'd put 1, I'd put 2, I'd put 3. I'm not trying to be extremely careful there. I'm just trying to make certain that I've got them on my graph. Okay? And then I would use a different color so that I could indicate it. Okay? And I would make an open circle around 3 and color everything off to the right of that. Why? Because x is greater than 3. That's what that's trying to tell me there. Okay? So how about this next one? It says m is less than or equal to 0. Well, that's simple. I'd start at 0, put it there, and it's going to be less than or equal to 0. So I'm changing colors again. I would color in a solid circle at 0, and everything less than or equal to that would get an arrow going that way. Third one there, it says t, and it's saying t is greater than or equal to 2.5. Well, I'd start at 0, I'd go to 1, I'd go to 2, I'd go to 3, like that. And since I've got negative, darn, Charles, -1, -2, -3, like that. Got to make certain I got those negatives in the right places, don't I? So -3, and it's at negative, t is greater than -2.5. I'd make an open circle right there. I'd probably identify it as 2.5 negative, and then I would color everything greater than that, going that way. Okay? That's the way you would graph these. Now, if I'm trying to interpret a graph, I can see the black circle through there. See a circle with a black on it? So that means it's got to be a less than sign. And I'm going to say that x is less than -1. Here, I'm seeing a solid end circle, so I'm going to say that x is greater than 6 or equal to 6. Almost caught me there. Solid circle. Got to be greater than, okay? Okay. How would I solve an inequality in one variable with a restricted domain? Well, what we're looking for there is this equation, and I want to make certain I solve that equation. Well, I solve it just like this was an equal sign. I do not pay attention to the fact that it's a less than or equal to sign unless I divide by 0 or divide by negative number. That's the only time I'm going to worry about it. So what I'm going to start with is I'm going to add 1 to both sides of the equation, and I'm going to get x over 2 is less than or equal to 2. And then I'm going to multiply by 2, and that's going to give me x is less than or equal to 4. Well, that's simple enough. 0, 1, 2, 3, and there's 4. And it's going to be x is less than or equal to solid 4 going that way. Okay? So guys, you get to have fun with crayons here. You get to color all you want. Okay, I said I wasn't going to worry about it unless I had a divide by negative sign. That's what I'm going to do on this one. I'm going to add 2x to both sides of it here. And I'm going to get a minus 5x is greater than or equal to 3. And I'm dividing by -5. When I divide by -5, my alligator turns around. I know. It's just what I learned in algebra. I say x is now less than or equal to 3 over 5 negative. So it's 3/5 negative. And I can do that very simple. 0, 1. Well, there's 1/5, 2/5, 3/5, 4/5. 5/5. So 3/5 would be right here. It's going to be a solid sign at that 3/5. 3/5 negative, and it's going to be everything less than or equal to that. Breaking out the colors. Get to play with colors. Okay? Moving on. Ooh, they're getting a little bit more difficult here. Well, remember, I still got that little line there. I've still got this symbol, and I'm not going to change that symbol. I'm simply going to do what I see here as if it was an equal sign. I'm going to have x plus 6 is greater than or equal to 3x plus 3 minus 11. Well, I'll combine these like terms there real quickly, and I'm going to get a minus 8 and 3x and less than or equal to x plus 6. Well, you know what? I'm going to subtract the x from this side because I like dealing with just smaller numbers like that. And I'm going to get 6 is greater than or equal to 2x minus 8. Add 8 to both sides of this equation, and I'm going to get 14 is greater than or equal to 2x. Dividing by 2, I'm going to get that x is less than or equal to 7. Okay, well, 0, 1, 2, 3, 4, 5, 6, 7. Change color so that you can see what I'm going to do with it. Okay, and its x is less than or equal to 7. Solid number, solid dot around the 7, and this way. Why am I coming this way? It's less than 7. X is less than 7. So it's got to come this way. Bounded equation. How would I do that in notation? X is an element of, well, it's going to be a square bracket 7, right? Wait a second. Made a mistake there and I want to correct it. Yeah, you're not doing what I asked you to do, pen. Made a mistake there and I want to correct it. Okay? Go back to my pen. Thank you. X, an element of open bracket negative infinity, comma, 7, close bracket, like that. Why did I write it this way? Well, 7 is the maximum number. I always want the max on the right side. And since it is a less than or equal to, I wanted the square bracket. Okay? The negative infinity, open bracket on that one. And it's going from negative infinity to that one. Always write the smaller one on this side, bigger one on the right side. Okay? So one more here. Let's see what we get. Okay, I'm going to add 2x to each side of this equation. I'm going to get minus 5x is greater than or equal to 3. Well, I'm going to divide by that negative 5, and I'm going to get x less than or equal to. Why did I switch the sign? Because I'm dividing by a negative 5. 3 divided by 5, negative. So I'm going to start right here at 0, go to 1. I'm going to get 3/5 in there. 1/5, 2/5, 3/5, 4/5, 5/5. So I want 3/5. It's solid circle at 3/5, and x is less than or equal to it. So it's going to be colored this way. How would I write that in notational form? Well, negative 3 over 5 is my high end. That'll get a square bracket on that one. Negative infinity is my low end. It'll get an open bracket, and x is an element of that set. That's how I'd write it in interval notation. Okay? Remember, I've got lots of courses out there. Please make certain you're always telling me that you're in Algebra 2, or else I have to go looking for you, and it just makes me a little bit happier, a little bit easier to find you and answer your questions. So, look forward to seeing you in Class Connect, and have a good week. Bye. Nope, that's not what I wanted to push.